Hi. Want to develop and rapidly prototype your brain-computer interfaces in Python? Try PyNoetic. PyNoetic is a modular Python framework primarily designed for rapid prototyping and development of synchronous brain-computer interfaces. Let's now go over each of the submodules present in PyNoetic. Firstly, we have the stimuli generation and recording module. PyNoetic offers both stimuli created for ERP, as well as SSVP. Both support customizable parameters like time period of each queue, time between queues, time to display cross, classes, and trials. Let's try a sample recording. Here, we get various stimuli on screen. Similarly, we can generate stimuli for SSVP. Let's select the color as red and time as 5 seconds to display flashcards. The module also supports recording calibration data for ocular artifacts. Moving on, the second module is channel selection. Let's select all channels and update channel selection. Now let's see top 5 channels according to common spatial patterns. Third, we have the preprocessing module. Let us apply a low-pass filter, say of order 15, and let's put the cutoff frequency of 10 Hz and apply the filter. Here, we can see the frequency domain response plot. We can also view the spectrum. So here no frequency is higher than 10 Hz. We can also view the filtered signal. To compare, we can see the raw EEG signal in the visualization module. Next, let's move to feature extraction. Here, we can select various time domain features that we want to extract. Then the features are used to train the classification model. Let's select random forest. After the model has been trained, it's saved offline. We now switch to live mode and begin simulation. So here is the simulation where we need to dodge the blocks, and as per the trained model, the block is dodged. We get visual feedback if we fail to dodge the block. Auditory feedback has also been introduced. If we switch to live mode, signals are analyzed in real time. We can see that right now the window is empty and the flowchart has just an input and output block. But we can load a flowchart and select some channels. Let's select 3 channels. Now let us see how we are pre-processing them. So we have a low-pass filter, an order of 15, a sampling frequency of 128 Hz, the upper cutoff frequency of 10 Hz. So here we can simply say high pass and we can introduce a lower cutoff frequency of 25 Hz. This makes the output change in real time. If we click on flowchart, here we only have channel selection and preprocessing. Now, if we were to add some more nodes, like if we wanted to have feature extraction, and, say classification, we can simply route the data through these by reordering the flowchart. This change is also reflected in the previous dialog box, where we can choose a particular classification algorithm in real time or a particular feature for extraction. By simply choosing a feature, they would get classified. For more details, refer PyNoetic's paper and its complete documentation.